everybody. I hope everyone has a beautiful start of the day as I have with you guys staying up into this auditorium. So, hi, I am your host for this beautiful morning. My name is RJ Krishna. You must be hearing me to your cars as of now. But today, for a surprise, you hear me on the podium. I would request all of the dignitaries, so would you please come and grace the dais with us so that we can proceed with our program for the day. Thank you so much, producer. And we actually begin firstly with the CSIR song. So I hope with this कि जितने उन्हें भी इसकी लाइन्स को बहुत ध्यान से सुना है perhaps मुझे और कोई तो यहाँ नहीं लेकिन हाँ वहाँ पर ऑडियंस साइड में जो दरिया बैठे उन्हें देखते हुए बड़ा अच्छा लगा कि उन्होंने पूरा ही डांस साथ में गाया था so congratulations to Imam for those songs हो गए जब हम बात CSI की कर रही है तो जरा उसके बारे में जानना भी जरूरी है हालांकि हमारा बर्थडे 26 of September को होता है because that's called as the day which had formulated all of us together to know what is CSIR in totality. लेकिन अगर हम बात करते हैं आज की, we are celebrating it क्योंकि उस तारीख पर हमारे यहाँ के सारे जितने भी लोग थे वो सब दिल्ली में मौजूद थे एंड वी हैड द सेलिब्रेशन देयर ऑल टुगेदर। लेकिन बात अगर सीएसआर की करें तो भारत की स्थापना इस वर्ष 1942 में की गई थी और ये एक स्वायत्त संस्था है तथा भारत के प्रधानमंत्री जो है इसके अध्यक्ष रहती है। बात सीएसआई की करें तो दे हैव इन फैक्ट 37 अकादमिक संस्थान का एक समूह जिससे गणती इनफैक्ट जिसकी सारी कैलकुलेशंस अगर हम करें तो हम विश्व के अग्रणी वैज्ञानिक तथा औद्योगिक अनुसंधान संगठनों में की जाती है। CSIR को 8,000 अनुसंधान विद्यार्थियों, 4,600 वैज्ञानिक तथा 8,000 वैज्ञानिक और तकनीकी कर्मचारियों की विशेषज्ञता और अनुभव प्राप्त है। अत्याधुनिक अवसंरचनात्मक सुविधाओं एवं वैज्ञानिक तथा तकनीकी कार्मिक शक्ति के साथ CSIR वास्तव में राष्ट्रीय तथा अंतर्राष्ट्रीय महत्व के वैज्ञानिक तथा औद्योगिक अनुसंधान एवं विकास के सभी क्षेत्रों में जैसे कि अंतरिक्षीय समुद्री अन्वेषण, माइक्रो इलेक्ट्रॉनिक्स के संरचनात्मक, पर्यावरणीय अभियांत्रिकी, स्मार्ट मशीनों से मैकेट्रॉनिक्स, पेट्रो रसायन से संश्लेषित जीवन विज्ञान तथा रोबोटिक्स और माइक्रो मशीन से औषधि तथा कृषि रसायन तत्व में ये सभी लोग कार्यरत हैं। So I believe we should all have a huge round of applause for all those people who work with the part of CSIR तो ये वाकई में हमारे भारत का कल्याण करती है। लेकिन चलिए अब क्योंकि यहाँ पर हमारे माननीय गेस्ट यहाँ पे मौजूद हैं, I would really request कि सबसे पहले अगर आप अतुल सर हमारे सामने देकर वेलकम कर सके हमारे डिस्टिंग्विश्ड गेस्ट को जो मौजूद है डॉक्टर रविंद्र त्रिपुरी सर हमारे बीच। इसी मुस्कान को आगे बढ़ाते हुए मैं रिक्वेस्ट करूंगी डॉक्टर अतुल सर से एक बार वो सामने हमारे बीच में पहुंचे और प्लीज वेलकम द एड्रेस ऑन बिहाफ ऑफ सर।
Very good morning to all. My fellow colleagues on the staff of NEERI, former staff of NEERI, still associated with NEERI, and all those who are directly and indirectly connected to NEERI. Welcome to celebration of this 82nd Foundation Day of CSR, which was actually on 26th of September, and all of us were expected to be in Delhi, all CSR laboratories, and even we had one exposition there. Displaying all CSR technologies. So it was a mega event in arranging CSR Delhi. And therefore, each laboratory was now allowed to celebrate as per its convenience. So today was a convenient day for us. And today we were expecting one political figure and the person who is getting very BCRO. But because he was summoned by PMO and he could not, I got a call from, we were waiting for him, that's why we were delayed. He had to travel to, he is going to Delhi. So I got a call from his team that he cannot come. And then Commissioner Ravi is anyway, anytime expected. But then we thought of starting the program because he is already with us. So anyway, Foundation Day of CSIR-NEERI is in April, and Foundation Day of CSIR is September. It is exactly kind of half-yearly review. I just put some figures before you, what NEERI has performed in the last 6 months. Total publications, although I personally don't believe in this criteria, but then publication is one of the criteria rank the institute or to gauge the institute performance. So far, we have 58 numbers of publications. In fact, of course, always here, good impact factor publications. And total impact factor so far is 326, which is good. So far, we have filed 4 patents in last 6 months. Copyrights registered 1 number. Our external cash flow so far is 15 crores around. It is again good. And I would like to mention here that this ECF is very ECF in the sense there is no outsourcing element involved in this. Mostly it is ECF. We should have good ECF, but we should not get carried away by all these figures. Basically, we should focus on the research, focus on the quality of research and the kind of standards our scientists will have in their research. You should be rated by your research, not by publication or the ECF or the projects which you do. You should be known by your research. That is what I expect, that is what people expect from any scientist. You should be versatile, you should be fundamentally correct, and you should be a good scientist, first of all. And there are many new projects. I would like to mention two, three things. The DST has given two big projects to Navy and money has also come. That is related to carbon capture and utilization storage. And one is for the river provision or what should be the impact of power plants on the climate change. There are two major projects which are they are awarded to Navy and not to mention all everybody, but Dr. Sarna was instrumental in getting these projects. I know since the beginning and let us follow. Second thing which I wish to mention specifically about the same scientist, Dr. Sarna. He was the very first scientist who was invited by none other than President for a special dinner on the eve of on the 15th of August itself. And that was a special dinner. And I think that is the greatest honor which any institute can get, or a scientist of the institute can get. Of course, scientist getting the honor is the institute getting the honor. So we are all proud of Dr. Sarna. He was the first scientist, even from NEERI, at least from NEERI, who was invited for such a dinner. And that is given for the distinguished work what any scientist carries in his lifetime, maybe in recent years, kind of recognition by a president. So again, big round of applause. And that is also achievement of NEERI, so we are all happy about that. Coming back to CSIR Foundation Day and the expectations of the CSIR. Now we are into a transition phase. That's what is transpired from all the meetings which recently we have been going through, and even it was indicated in the meetings which were in and around 26th of September in that mega event at Delhi. A lot of transformation is going to happen in CSIR, and there can be a lot of challenges. First, foremost challenges will be regarding the manpower and then availability of the many things which we are not accustomed to. We'll have to adapt ourselves to new systems. One big example is e-office, which is going to be implemented very soon and it will be under compulsion. All of us, including me, we are reluctant to any change. जब भी नया सिस्टम लगता है हमें इसमें क्या करना है उसमें क्या करना है, so we normally try to shun away from that, but that is not the time we will have to adopt those things, because that is going to save manpower, that is going to save a lot of documentation, that is going to bring transparency in the system, and transparency is going to be the key in coming years, whether it is financial decision, whether it is scientific or administrative decision. One more thing is that manpower recruitment we are trying to push in NEERI also, in all categories, scientific, technical and administration. I am trying to push first recruitment of administrative cadre, because administrative cadre is required to even be carry out the processes for technical and scientific manpower recruitment, and we don't have sufficient manpower. And there are many formalities, many procedures that we follow. I hope our administration is taking good care, and shortly we will be recruiting good administrative staff so that most of our other things can be taken up. Manpower, we keep on getting complaint manpower, and we will have to sustain that. It's because government is of the opinion that we have more than enough manpower. If we compare ourselves to corporate sectors or private sectors, there was an argument once long back that our salaries are different or much less as compared to corporate sector, so our manpower is more. After 6th and 7th pay commission, probably that is not really a theme. The government is also aware of that. So when you are getting good salaries around, manpower will be less and we will have to sustain that. We have to take up many challenges, including climate change and our routine things we cannot give up. Which we keep on saying always in all meetings that we are into organizations like environment and we cannot stop old areas of research. Like we cannot stop air pollution, we cannot stop water pollution research, we cannot stop wastewater, but we have to keep on adapting to new things like circular economy, climate change, and machine learning, artificial intelligence, and so on. So our spectrum of our work is going to increase, but manpower will be less, and we will have to sustain it. So I think we are all capable of putting up the challenges and we try to collectively cope up these challenges. Of course, whatever facilitation is required for management, that will do. Secondly, which is the important thing which I want to place on the record is that many of our senior colleagues are going to superannuate, including me next year. And pattern of NEERI is going to be in the hands of middle management. So I request all middle management, those who are in the levels of F, G, and A2, they have to come forward without complaints to take this baton. Otherwise, NEERI will sink. Recruitments are not going to be fast. There is a move in CSIR where all recruitments at every level will be centralized, so it will be not in your control. So we have to be geared up. Middle management has to be geared up to take the pattern of NEERI ahead in the years. And this is the time to get yourself groomed, get yourself tuned to the new things. And I am fully sure and I am fully assured that all middle management is ready to take up the challenges. There can be some complaints, but anyway, we can take up the challenges. So that is one thing. And lastly, in coming years, not only you have to do the research, you have to do the research for society. Question is always asked, what NEERI has done or what CSR has done for society. And if we really carefully go through that, we have done a lot of things for society, indirectly or directly. But we are unable to pinpoint specifically, like ISRO can say, we have sent Chandrayaan, and they are appreciated for Chandrayaan. BRC can say, Mohammed Sola make their reactor this and that. Self-sufficiency in nuclear weapons. DRDO can say of missile. I am talking about government departments. We cannot say directly. One more difference that CSR major challenge is that BARC, DRDO, they have fixed customers. ISRO, fixed customers. CSR, the government will ask CSR to compete with Ion Exchange, compete with Reliance, and compete with all international multinationals for the technologies. And therefore, our challenge is much bigger. And always don't be proud of what we are doing. We have to just pinpoint exactly, we have to narrate what CSIR in general and what NEERI is doing for society, directly or indirectly. Suppose a scientist or our team says that we have facilitated one EIA project. That means actually you have facilitated one industry to do an environmentally sound job. You have facilitated hundreds of employments there, and you have facilitated national development. So this is the way you have to do it, and we have to learn those things. So far, we are not tuned to that. So these are the things which I wanted to put forward in this particular time of CSR Foundation Day. We are doing well, and as usual, I say, and I say it honestly, nothing direct. I have just to push the matters. That's all. Everything, all these records which I read here, it is to your credit, nothing from my side, and I will not take any credit of that. It is all your credit. Keep it up, and I am sure that you will double this thing in coming 6 months. Thank you very much. All the best for the CSR.
Thank you so much for your wonderful words. And I always reminds me of the saying that says that, to handle yourself, you really need your head. But when you really need to handle others, you use your head and your heart the most. And so, undoubtedly, I'm sure you must be using both of them to control such a beautiful power you have with us. But on that note, we also have our distinguished guest amongst with us, Dr. Ravindra Guri sir, who is currently the Dean at the Alumni of Corporate Relations at IIT Mumbai. Prior to this position, he was the professor in charge of the IIT Bombay Research Park Foundation and has also served as head of the Department of Chemical Engineering. He is also professor in charge of continuing education and quality improvement program at IIT Bombay. He also holds the institute chair position in artificial intelligence and machine learning. He earned his BTech and MPhil degrees from IIT Bombay and PhD from the University of Alberta in 1995. His research interests lie broadly in the process systems of engineering and green engineering, that is modeling, optimization, control and fault, diagnosis of process, system sustainability and industrial practices. Dr. Guri has published over more than 150 focused in-depth papers and has 9 US patents to his credit in various areas of process systems of engineering. He has guided over 60 PhD and MTech students in research at IIT Mumbai. Dr. Guri is also a fellow of INAI and a recipient of several awards, which includes the Canadian Commonwealth Fellowship by the Government of Canada, the Raviraj Kumar Memorial Award for Promotion of Industry and Academia Integration. We've also got the Manudhani Applied Research Award. We've got even the Khadija Award for Excellence in Basic Chemical Engineering. And he's also an associate editor of the IFAC Journal of Process Control and the guest editor for Control Engineering Practices. He serves on several technical committees of IFAC, and he's also been an active consultant to the industry in India and also abroad. With this, I would really love to have Dr. Ravindra Guri with us to kindly share his few words with us.
Namaste, good morning. Firstly, it's a pleasure to be here at NEERI. We have leaders in the organization. It's a pleasure to be here at NEERI. I'd like to extend my heartiest congratulations on the 82nd Foundation Day, BB and CSIR. I think from IIT Bombay, what we know about NEERI has been a place to go as far as all environmental related research is concerned. And it's really a place where we hold a very high esteem across all research activity that's happening at IIT Bombay. The CSIR lab and it has done outstandingly well. And I would like to extend again congratulations to all the technical staff, the scientists, and the leadership of NEERI for all the achievements so far. And I wish that these activities will continue to soar and have several impactful contributions to the nation and as well as globally. So once again, my heartiest congratulations. I'm really thankful to Dr. Atul Vaidya, Director NEERI, for this invitation to be here. Of course, we share a common, there's something common in us. We have the same alma mater, IIT Bombay, and his eminent leadership qualities were even evident during that time, which we see also evident today in terms of his stewardship of this great institute. I would say that, if you look at what pace NEERI holds nationally, if not globally, I think the times are very, very relevant now with climate change as a threat. But climate change typically is associated with what we observe. We look at climate pattern changes, heavy rainfall, deterioration in air quality, and so on. But there are a lot of latent things that are also happening which are not so evident, and NEERI has been contributing very strongly to all of that. We all know about the Pancha Mahabhuta, which is rainwater, fire, earth, and ether. This is basically what has made nature survive billions of years, as far as we can tell. And this delicate balance amongst these 5 elements is very, very crucial for the overall sustainability. And we need to make sure that we don't alter that balance, we don't vitiate that balance. So it's very, very important that we consider the deterioration along each of these 5 elements, but more importantly, the nexus between all of those, which is very, very crucial to make sure that what we call as nature capital, we talk about capital in terms of wealth, investment and the like, but nature provides a lot of capital. The ability of nature's capital, the ability of nature to nurture us has to be sustained. And for nature to be able to nurture us and that ability to be sustained, we have to also be responsible. We preserve the ability of nature to nurture us. That's what I think is the central theme of what we are looking at now with local practices, all that we do in our anthropogenic activities, local practices having global impact as well as global policies having a local impact. And all of these we need to understand, we need to factor in, we need to make sure that the policies, science and technology, the management of our environment is all well aligned in a manner that again the punchline is preserving nature's ability to nurture us. So I would say that this is just a while we celebrate the Foundation Day and we celebrate the accomplishments of NEERI, this is one other touch point where we need to keep reminding ourselves about the important role that we need to play in preserving that balance. I'll just very quickly in the next 20 minutes or so share my thoughts about what I feel about sustainability. Of course, there are a lot of scientists and experts here who can do that quite well. So I just want to step back and say where we are today. These are typically the several waves of innovation as we call it. In the early 1800s, you see, mid 1800s, all of this was driven towards making life for a human being or mankind more comfortable. So the first wave was water, power, mechanization, textile, commerce. We wanted to basically discover, invent all of these to make our lives comfortable. The second wave was wanted to now explore the world. So steam power, railroads, steel, cotton. The third wave was, okay, can we now be less uncertain about our environment? Can we bring in electricity? Can we bring in chemicals, the internal combustion engine to travel? The fourth wave was petrochemicals, electronics, aviation. Fifth wave, somewhat we are experiencing now, digital networks, biotechnology, software, information technology. But in this drive towards making life for ourselves more comfortable, are we overdoing it? Are we using technology in ways that is going to vitiate this balance? And that is where you see the sixth wave, now the topmost, amongst the topmost, is sustainability, radical resources productivity, holistic system design. Basically looking at it end to end. There's nothing like a waste in this holistic system design, waste to value kind of aspect, green chemistry, industry ecology, renewable energy, green nanotechnology. All of these are now coming up as the sixth and in future the seventh waves and the like. What we are experiencing now is indeed very, very relevant. And why I'm putting on this slide here is because central to all of this is what you as scientists are doing at NEERI in trying to look at all of these aspects. Okay, now, what is human well-being? Let's step back and see what human well-being. Basically, it's a state of health, happiness, and or prosperity. There are different ways by which we can understand well-being. It could be physical well-being, psychological well-being, economic well-being, environmental well-being, social well-being. And all of these are not independent entities by themselves. There is an overlap amongst them. The overall well-being of a person is dependent on all of these aspects. And what promotes this kind of a state of health, happiness, it's basically our ecosystem, goods and services. There's a very simple chemistry equation that I put there, which we know is nature. It's fixed combination with water and sunlight, make sugar and oxygen. We all know trees grow, forestation, all of these, Vrikshavali, Amasari, we know this. This is central to everything that we do in terms of biomimicry, the cycle of carbon, right? Now, if you look at it and step back, what are we doing now? We are actually producing carbon dioxide, But there are not enough sinks in carbon dioxide, as you all know, because of the increasing deforestation, increasing usage of fossil fuels in the industrial growth to make life more comfortable for us. So we are becoming increasingly linear than cyclic. And it's important that we remember this equation and try to make things as cyclic as possible. The ecosystem goods and services are basically minerals, fossil fuels, water, soil, air, oxygen. All of this is basically available for free for us. We assume that it's available for free. I think we need to start thinking whether it should really be free. Okay? Look at services that the nature offers, regulation of climate, regulation of water flows, nutrient cycling, pollination of flowers, soil formation. That in many ways contains all the five elements: wind, water, fire, earth, and ether. Right? Most of these are, as we know, getting increasingly degraded. They have climate change, experiencing that loss of biodiversity. Philosophically, biodiversity is a very, very important thing. Right? Each entity has a place in the universe. We seem to think some are less important than the others, but it's not the case. We want to make sure that we preserve the biodiversity. The collapse of fisheries and coral reefs, plastic pollution in the oceans, soil erosion, desertification, reduction in water tables. All of this because, as I say, enough for everybody's need, but not enough for everybody's greed. Human actions are responsible for this severe degradation. We just need to re-regulate, look at our practices a little more closely and make sure that we kind of bring in a sense of balance and sanity in all our behavior. Climate change, this is just a doomsday picture. You can recognize the area of India, 2 degrees the tipping point, 4 degrees you see half of it being submerged. We know about this already. So let's give this, why have we come to this point? We are focusing primarily on growth and less on development. It's high time that we start looking at development. Development is inclusive of growth, but development also entails a lot more. And that's something that we should look at. Okay? Let me come to the point directly. Green engineering. What is green engineering? It's basically the design of products, processes, and practices that are sustainable on a life cycle basis. I talked about exploitation of fossil fuels. This is more linear in nature. There's less of an opportunity for it to be cyclic because of our deforestation and because of the nature sinks not being able to absorb the carbon dioxide. Can we use the same technology that we develop for our growth and adapt it to make sure that the advanced technology can also handle the problems that it creates, which is buildup of carbon dioxide, deterioration in soil quality, look at the water. Can we use advanced technology to solve this problem? Right? The technology fighting its own evils is something that we're talking about, and that's what green engineering is all about. Prevent waste and then treat the waste at the end, integrate production practices to minimize waste, look at it in the systems engineering approach, end to end. Might become fairly complex, but now with advanced tools, both in mathematical as well as linguistics, we do have a significant, I would say, technology capital to be able to address some of these problems. So that's something that we need to do. This is a slide that we need to understand very, very closely. Basically, there is an exchange of mass, material, and finance across these 3 entities that you see here. The ecosystem and the environment, which we call very broadly as nature, industry and development that makes our life more comfortable, and of course, society and consumers. What we borrow from the ecosystem, what society and consumers borrow from the ecosystem is sunlight, clean air, water. What we return to the nature is emission and waste. What industry borrows is resources and feedstock. What it returns is byproducts and waste. Whereas what we are focusing increasingly is only on this aspect, which is society and consumers, the value additions and the financial flows. It's time that we start looking at all of this because we want this direction to be sustainable. We want this direction to be sustainable for an extended period of time. We want to minimize this direction and this direction, right? So basically what sustainability, as we all know, is of course we want to have progress, of course we want to have growth, of course we want to have development, but not at the expense of our future generations. Right? That's the key. So I just, this broad statement, I just talk about what sustainability is, but more importantly, bring this aspect of green engineering and green chemistry, which are now becoming increasingly central. There are several principles of green engineering. there's this classic book by Mr. and Zimmerman, which focuses on all of these aspects. For instance, material and energy outputs are inherently non-hazardous as possible to them. That way, prevent waste and treated. Make sure that when you do separation and purification, they should minimize energy and material use. Products, process, and systems should be designed to maximize mass, energy, space, and time efficiency. We have been doing this, but relatively lesser attention because our capital is nature capital. We are estimating it to be free. No longer is the case. Products, processes, and systems should be output pull rather than input push. So you don't want, for instance, just as a practical example, if you are staring at a steaming, delicious plate of samosas, our natural tendency is to pick that and pop it in our mouth, no matter whether we are hungry or not. That is input push. It's not output push. It's not hunger driven. It's just input push, right? It's time that we start looking at these aspects a little more closely. Make sure that our products or processes are output push and not input push. Embedded entropy is a slightly more complicated aspect of entropy, which probably we can discuss at some other time. Targeted durability, not immortality, should be designed. So it should be durable, it should be targeted over a particular duration, it should not be immortal. That should be so that you can recycle it and make it cyclic. Designed for unnecessary capacity should be avoided. Material diversity should be minimized. Design of products processes must include integration, interconnectivity. Product processes should be designed for performance in the commercial afterlife. All of these, we know this in some way or the other, but it's time that we now bring them in a much, much stronger way in everything that we do in our industrial design as well as in our practices. In parallel to these principles of green engineering and also these principles of green chemistry, which is again very, very important. Some of these, for example, prevention is common atom economy, embed everything that you do as input reactant. Make sure you maximize its incorporation into the products. Several of these are already listed out there in this book, but this is very, very important to now reconsider and bring them more, spotlight them more strongly into focus so that we stay relevant. So what I will do is I'll just walk you through it, in the interest of time, walk you through some quick examples. Okay. The first is, of course, importance of product design in green engineering. There are now several advanced tools that allow you to do that. Basically, product design becomes a tool to promote green engineering. The moment you design your products keeping green engineering concepts in mind, it becomes a lot more easier. I'll just show you one example now of CO2 capture and conversion. People are talking a lot about it. Carbon capture, usage and storage. The question is now, you capture carbon, which comes at a cost. You store them underground, which comes again at a cost, but you don't know what's happening in underground. So therefore, the CO2 can react with water, form a weak carbonic acid, cause soil internal structure implosion. Are we prepared for that? We don't know. What does nature do with carbon dioxide? We saw that chemistry equation, which is carbon dioxide plus water in presence of sunlight becomes carbohydrates. Can we use our understanding of chemistry or advancements in technology and mimic that reaction? I'll just walk you through a simple example of how we can look at CO2 and convert it to value-added chemicals rather than just inject it into the earth, capture and inject it into the earth. I don't think I'll spend time on this slide. You already know this. The bottom line is a third of the GHG emissions and half of CO2 emissions come from stationary fossil fuels and resources. There are several ways which we can look at. I think I'll skip this slide in the interest of time. I'll just show you a very simple schematic. If you know power plants generate power, they take in fossil fuels like coal, they burn them, they produce carbon dioxide. So to complete this, there is electricity generation, carbon dioxide, which conventionally is now being emitted. Right? What we could perhaps do is, remember this reaction again. This reaction is what nature does. Can we do some form of a reaction which fixes the carbon dioxide and extends the life of a carbon atom as it goes through this entire process? Can we carry out something called as an artificial partial photosynthesis? So what we do is, instead of carrying out this reaction, we say let's break it up into carbon monoxide and half mole of oxygen. If we are able to do this, that's a big if, which our technology will help, our understanding of technology will help. We can potentially make this cyclic. How? Because now you have split carbon dioxide to carbon monoxide and oxygen. separate them out, send the oxygen back to the combustion. The oxy combustion happens, higher efficiencies. Take this carbon monoxide, run it through a water gas shift reaction, produce the hydrogen. The remainder of the carbon monoxide hydrogen forms a synthesis gas, and in many ways this becomes a cyclic process. Okay, so a quick analysis of this actually shows that it is feasible if you use methane. Use 1 mole of methane, the energy ratio needed to energy generated is about 0.75. Therefore, for every kilowatt of energy that you generate, 0.75 goes towards the cyclic process and 0.25 is available for you for power generation, electricity generation and the like. So this is not an infeasible process. Technologically it is feasible if you are able to crack this nugget. And now you see a lot of recent papers which talk about plasma-based reactors for carrying out CO2 partial splitting to carbon monoxide and oxygen. Right? So this is certainly a feasible thing which can be done. We did a similar analysis for coal. As of now, it is not feasible, but certainly with advancements in technology, that can become feasible. Okay? So, in the systematic process of trying to understand what technology can do, you need to look at which are the difficult nuggets in the entire value chain that you need to track. And here is some of those, for instance, the process challenges, the research trends. They talk about development of thermotolerant catalysts for CO2 splitting. High rate of splitting reaction is required, high conversion efficiency, membrane separations, nitrogen separations, and the like. If you are able to identify this and pursue these research problems, you would actually make it feasible even for the coal power plants. And natural gas power plants anyway is feasible. Coal power plants, we have to make it feasible. This is possible. So I'll go to the second example here. We talked about carbon dioxide, which is more from the air point of view. We also need to look at liquid discharges. When looking at liquid discharges, basically you are not using the right amount of solvent, the green solvent that people are talking about, that can be reused over and over again and not have any discharges, right? So there is opportunities where ionic liquids, but you must have heard of ionic liquids. These can be used because these are low vapor pressure, reusable, biodegradable kind of liquids. And I'll just run you through a very quick example of lignocellulose. We talk about lignocellulosics for energy generation, for liquid transportation fuels. Here is one example where we came up with using our understanding of molecular design, computer-aided molecular design, to come up with ionic liquids, novel ionic liquid solvents, which can basically be used in a cyclic manner to carry out the separation between the lignocellulosics from the cellulosics from the lignin. This is one example. Basically, what is currently being used, for example, acid-based steam explosion, ammonia fiber explosion, organic solvent extraction. While these are good as technology, they generate several byproducts. But make sure that it can reduce these. And so the question is, can we come up with selective lignin extraction using ionic liquids? Ionic liquids, what we know about them, and can we look at effective design of an ionic liquid? So here we use basically the computer-aided molecular design. When you bring anions and cations together to constitute an ionic liquid, there are several possible 10 to the power of 14 cation anion combinations. Some of these you can just discard on observation, but quite a few of these are potential candidates for constitution of ionic liquids. So you can look at some of the physical properties, correlations to predict using quality structure property relationships, look at some selected properties from the targeted ones and solve the problem. In this case, for example, for the lignocellulose case, the selected properties were H bond basicity, melting point, viscosity, but most importantly, the Hildebrand solubility parameter. When a solute has to get dissolved into a solvent, then Hildebrand solubility parameters must be close. So we look at close to that of lignin. We want to dissolve lignin, so we want the ionic liquids structure to have a solubility parameter as close to 24.6 as possible. Formulated that as an optimization problem, combinatorial optimization problem. But now with the advancements in mathematical theory, there are enough ways to solve this mathematical problem. We looked at different ways of doing that, and eventually, so this is the target property, 24.5. This is the predicted property using structure property relationships. Evaluate several thousands of cation anion combinations, and eventually came down to a few of these which potentially came very close to 24.6, and this is something that we use in demonstrated experiment. Okay? So this is another way where we look at our understanding of technology, our ability of advancements in mathematical theory to come up with ionic liquids as green solvents to be able to solve that problem. The third example that I'm going to take very quickly is that of atom economy. I talked about when you develop a product, you want to embed all the reactants as much as possible into the products, right? So that there is no waste, so there is no emissions, there is no discharge, right? So how do we look at this redesign in the chloromethanes industry? Chloromethanes, as you all know, carbon tetrachloride is chloroform, but there are several other derivatives of methane. Typically, this is the first derivative, second derivative, third derivative, and this is the carbon tetrachloride. Okay? Now, when this is being made for various industrial uses, each of the steps emits 1 mole of HCl. Now, you are designing the process to come up with 1 mole of HCl as a product, a byproduct, and then to prevent, before it gets discharged, you are going to neutralize it, you are going to treat it at the end of the pipe. Can we avoid the HCl formation itself? So redesign, or if we cannot, we have to rely on the chemistry. Can we do something with that HCl so that we can recycle it? Because remember, HCl is also reactant. Chlorine is also a reactant. Right? So this chloromethane synthesis was looked at a little more closely using process engineering tools, looking at modeling, looking at optimization to improve efficiencies, look at synthesis of better reaction routes so that they are able to minimize the discharge of HCl. And very quickly, this is an Aspen simulation, consists of a reaction, a separation of excess methane and HCl absorption, and then the chloromethane's product recovery. This is a conventional one as practiced in the industry. Looked at alternatives where we could improve the efficiencies, and this came up with absorption of HCl in the chloromethane mixture as one of the possible process alternatives that helped capture the HCl. What do you do with the HCl? And that also was still a big question mark. Did heat integration? Now, heat integration is important. Heat integration has been a research area for the last 3 decades. Heat integration is important. You certainly need to do that. But material integration is also equally important. And this is something that we still are not facing significant research emphasis. This step looked at material synthesis as well. And just very quickly, in the interest of time, go through the what we did was to bring in material synthesis. We looked at modified decon process, which is a 2-stage process, gives 76 per pass conversion of HCl. This was an expired patent, nobody was using this. We said, can we do an air oxidation in presence of iron of this HCl, anhydrous HCl, and make chlorine out of it? So if we did that, so this is the HCl catalytic air oxidation. The product contained anhydrous HCl. You air oxidize it with air, generate chlorine, and it comes back here. So remember, the chloromethanes industry is a reactant as well. So now instead of discharging HCl before discharging, treating it, neutralization and the like, now what we are doing is we are looking at this anhydrous HCl, subjecting it to air oxidation in presence of iron, and bringing chlorine back. So now what you have is in each of the chloromethane molecules that you generate, all of the chlorine gets embedded into the product. There is no emission or discharge of HCl, and this basically promotes atom economy in terms of chlorine, making sure that there is no discharge. So now you need to look at all of these aspects. Theoretically, chlorine efficiency becomes close to 100%, yield of the product, no end of the pipe treatment, and so on. So all our current industrial practices, what we are currently doing, industrial synthesis rules, these need to be looked at in a very, very rigorous manner, looking at opportunities for design of greener solvents, looking at opportunities for making the process as cyclic as possible, and looking at more synthesis routes that, when you retrofit or when you design your processes, we are going to make a significant impact on the way we conduct our industrial practice. Okay? So this is really what I wanted to say. There are a few other slides which I will not go through. This is more on the sustainability and water drinking water distribution systems. I just want to highlight, just going back here, one of the research areas which is currently quite exciting in my research group, and that is associated with this reaction, right? we have carbon dioxide and nitrogen coming out. Now this nitrogen, presence of air, reduces the overall efficiency of combustion. You can get a maximum of 50% efficiency because nitrogen takes away a lot of the sensible heat. Right? The reason why we are using this process still is because air contains significant amount of nitrogen. Air is a source of oxygen. It contains significant amount of nitrogen. Can we supply that oxygen to the coal without using air? Okay, that's one question. Naturally, somebody says, come up with oxy-combustion, put an air separation plant, separate out the nitrogen, use the oxygen, and do the combustion. Yes, that's one way that will increase the efficiency of your combustion. However, air separation plant comes at a significant cost. So now, are we willing to do that balance? There is another very interesting development in research which says looping combustion. A looping combustion as such is not new. If you look at the fluidized catalytic cracking unit in a refinery in a petrochemical complex, catalysts crack the crude, they get deactivated, they are regenerated in another regenerator, and the catalyst is looped. It has been a very mature process for the last 5 decades. So looping is not new. The question that we ask here is, can we supply the oxygen using looping combustion? And the answer is yes. Transition metal oxides like Fe2O3, they go through two oxidation states. One is FeO, the second is Fe2O3, Fe3O4. Right? Can we now come up with a looping mechanism where we don't subject the coal to air, we subject FeO to the air, convert it to Fe2O3 or Fe3O4, so it goes to a higher oxidation. Then you take it and bring it in contact with the fuel, so that it exchanges its oxygen with the fuel, comes out spent, and gets looped repeatedly. So now what you have is the air does not come in contact with the fuel. It is the catalyst, or in this case, the transition metal oxide that comes in contact with the fuel. What that helps do is, here there is no nitrogen now, it becomes a pure stream of carbon dioxide, which can be either sequestered or converted to value-added chemicals. So current research developments are in this area of looping combustion, where it will generate power as well, it will generate pure stream of carbon dioxide and make it amenable for both supply of stream for value-added chemicals or for sequestering. Right? So this is also something that our understanding of science, our understanding of technology basically helps us to think of these novel routes from business as usual to business to be. We certainly want to increase our power requirements. We certainly cannot do it with our dependence on coal. But can we have better combustion technologies that produce pure carbon dioxide, which is something that we can use, make cyclic and so on. Right? So this is something I wanted to highlight. I wish to thank you for your attention. And again, I wish to congratulate the entire CSIR community and particularly the NEERI for all their accomplishments and achievements over the last 82 years. And congratulations again, and it's a pleasure to be here. Thank you for your kind attention.
Thank you so much, sir, for the wonderful presentation. And I hope there's a lot of people out here who must have been inspired by what next could be achieved up in their life. But now we move forward. We're now going to be having over the felicitation of CSIR-NEERI employees who retired on the superannuation during September 2022 and August 2023. So now I request all the dignitaries to please come up a bit forward so that we can have all of them up here one by one. So we start with the first person, who is Mr. Shri Sharan Kohar, who is the ex-work assistant CSIR and NEERI sir. Can you please come up on the stage, and we would love to present you with a moment to short and give us some mark. इनके बाद में मैं गुजारिश करना चाहूंगी श्रीमती पी कृष्णा बेनी, the ex-finance and accounts officer of CSIR and NEERI, to please be up here along with us. Dr. G.S. Bode, the ex-chief scientist and the head of QNS division CSIR-NEERI to please come up. मुझे पता है जिन्हें एक्चुअली कुछ नहीं मिल रहा होता वो यही सोच रहे थे हम यहाँ पे पर जिन्हें मिला है उनके लिए ताली बजी हो गई इसके बाद I would request Shri Dharapal Harki sir, ex-work assistant of CSIR-NEERI to please be on the stage with us. I would request Dr. Mrs. Neha Deshpande, ex-senior technical officer CSIR-NEERI, to go to किसी वक्त के साथ हमारे साथ स्टेज पर हमारे होने को. The next person to be felicitated is Shri Ajay Shankar Dubey, sir, the ex-principal technical officer CSIR-NEERI. I believe he does not hear anyone on his behalf if they would want to come and accept this, we would really love that. We will move forward. We'll have Shri Deepak B. Barge, sir, the ex-senior technician of CSIR-NEERI along with us. किसी कारणवश हमारे बीच श्री पीजी राजेश सर जो ex-senior technician है CSIR-NEERI के ऊपर नहीं है, but still ये certification उन्हें भी पहुंचता है. Moving forward, we have Shri Arun Sharma sir, the ex-senior technician CSIR-NEERI along with us. So once again, a huge round of applause for all the teachers who will be employed to retire on superannuation during September 22 and August 23. Moving forward, guys, now we have another group of felicitation to honor CSIR-NEERI employees who completed continuous services of 25 years in CSIR during September 2022 and August 2023. We will request सबसे पहले Dr. Girish Gopani sir, to senior principal scientist at CSIR-NEERI to kindly come up on the stage, please. मेरे ख्याल से जितने सालों का एक्सपीरियंस इन सब का है अगर हमने इतनी भी तालियां बजाई तो शायद वो काम नहीं. Thank you so much. Moving forward, I would request Shri Dayanand Nayak sir, who is the work assistant person for CSIR-NEERI, to please be up. Shri Rajesh Bode sir, the technician for CSIR-NEERI, to please be up with us. I would request Shri Sanjeev Ankare sir, senior technician at CSIR-NEERI, to ask the next exercise. Do you have it? Yes, you do. Shri Sanjeev sir के बाद में we would request Shri Bandhu Tripuri sir, the senior technician for CSIR-NEERI, to please be with us. Senior technician for CSIR-NEERI, आप भी यहाँ हैं, please मंच पर आएं. माननीय के बाद में I would request Shri Sachin Bhumre sir, the work assistant for CSIR-NEERI, to please be up here on the stage with us. Now, the noble release, I would request Dr. Sandeep Bhore sir, the chief scientist of CSIR-NEERI, to please be up here with us. Ladies and gentlemen, these are all those people who have completed the continuous service of 25 years किसी भी जिसको अपने 25 साल देना कोई कम बात नहीं होती और इन सभी के लिए एक बार जोरदार तालियां। In fact, अपने आप में एक बड़े कमाल की चीज है और अब हम एक सर्टिफिकेट ऑफ अप्रिसिएशन देना चाहेंगे मास्टर प्रवर जैन को मिस्टर हेमंत एस जैन सीनियर टेक्नीशियन ऑफ CSIR-NEERI इन्होंने 90% से ज्यादा मार्क्स स्कोर किए in 3 science subjects in the senior secondary examination of class 12. And now moving forward, आपको हम बता दें कि इनफैक्ट नीरी CSIR ने हम मिलकर कंडक्ट किया था जिज्ञासा साइंस मॉडल कंपटीशन। इसमें बहुत सारे स्कूल्स ने हिस्सा लिया है एंड आई एम श्योर ऑल द स्टूडेंट्स एंड द टीचर्स आर क्वाइट एक्साइटेड टू नो कि इसे जीता किसने है। ऑलराइट, सो लेट मी टेल यू दिस, हमें भी साथ ही बड़ी जिज्ञासा है। कैटेगरी फर्स्ट हमारे यहाँ पर 5th से लेकर 7th स्टैंडर्ड के बीच में थी और इसमें जिन्होंने फर्स्ट प्राइज जीता है वो है भवंस बीपी विद्या मंदिर सिविल लाइन्स नागपुर जिनका मॉडल था ऑटोमेटिक गार्बेज सेग्रीगेटर विद ड्यूअल एक्सेस सोलर चार्जर, राइट? Come up here on the stage, then it's all yours. Congratulations to the students who actually taken up the role with an interest in the subject as it is. और इसके बाद भी we are talking the smile says it all. खूबसूरत मॉडल को जानने के लिए आप ऑफिस टीम बच्चों से मुलाकात कर सकते हैं। लेकिन इसके बाद नेक्स्ट मूव फॉरवर्ड सेकंड प्राइज जो श्रेणी हमारी 5th से 7th स्टैंडर्ड के बीच है इसने किसे हासिल किया है? तो वी गॉट सेंटर पॉइंट स्कूल काटूर रोड नागपुर से जिन्होंने बड़ा खूबसूरत मॉडल तैयार किया था इंटीग्रेटेड फार्मिंग एक खेत एक तालाब। कांग्रेचुलेशंस गाइस, यू आर द सेकंड प्राइज। I'm sure the teachers are going to be as excited. Moving forward, any guesses who has the third prize? Any guesses by the students about जो वहाँ खड़े हैं बेचारे? Okay, let me tell you. School of Scholars, Beldarodi Nagpur, आप जीतते हैं the third prize, and we have made up of a model which was automatic smart street lights. Congratulations, guys! I really wish अगर यहाँ पर हमारे बीच हमारे बाकी के गेस्ट होंगे कि हमारे नागपुर शहर में इसकी सबसे ज्यादा जरूरत है for automatic street lights to have it up. Moving forward, we have a consolation prize given out of the same category. We would request the students from St. Joseph's Convent Kingsway Nagpur to please come up here and receive your consolation prizes. इनका मॉडल था solid waste management. Congratulations once again. So ये सारे साइंस मॉडल कॉम्पिटिशंस के हकदार हैं सारे अवार्ड्स जीतने के and they have made some fantastic projects in the last year. Moving forward, जिज्ञासा की एक और सीट पर हम पहुंचते हैं कैटेगरी सेकंड which was 8th to the 10th standard. इसने कौन सी स्कूल में बाजी मारी है? Let's have it up here. The first prize goes to Center Point School, Katur Road, Nagpur, for the model, the story of dry gold and green lungs. Congratulations! बच्चों की तो तालों के साथ हौसला अफजाई होती है। Alright, moving up to the second prize in category which is 8th to 10th standard, we have got Montfort School, Ashokwa, Nagpur, जिन्होंने मॉडल बनाया था the Wi-Fi data transfer system for environmental protection. So can we have the students of the school, please? So there they are. Alright guys, so that's the Montfort School, Ashokwa, Nagpur, जिनके बच्चे फिलहाल हमारे बीच यहाँ पहुँच रहे हैं। And it's so good to see कि सारे प्रोजेक्ट्स फिलहाल environment based थे और ये बच्चे अगर 5th स्टैंडर्ड से ऐसे मॉडल क्रिएट करते हैं, they have a better future to live here. Moving on, the third prize we got K. John Public School, Asoni, Nagpur, और इन्होंने मॉडल बनाया था pyrolysis, the waste plastic to fuel. Congratulations, guys! I suppose the 80s के बच्चे, 90s के बच्चे ऐसे मॉडल तो नहीं बना लेते. What they have been doing so far. We also have a consolation prize in the same category, and that goes down to Deenanath High School, Nagpur, जिनका मॉडल था sustainable development. Do we have the kids from Deenanath High School here? Okay, so we believe they're not with us. Fair enough. Moving forward, now we come down to the category 3, that is 10th standard to 12th standard. The students who are actually going to be laying the future for us right now. इसमें first prize किसने जीता? We've got Sandipani Junior College, Hazari Pahar, Nagpur से जिसका मॉडल था Bio-Green Methods of Waste Treatment and Water Management. Congratulations, girls out there. Moving on to the second prize in the same category, we've got King John Public School, Asori, Nagpur, जिनका मॉडल था Sewage Treatment Plant. So students from King John Public School are invited here. In the same category of 10th to 12th standard, the third prize goes to School of Scholars, Vanadogri, Nagpur, जिन्होंने मॉडल बनाया था on air pollution control. So students of the scholars basically are out here amongst us. Congratulations to all the students and teachers who participated in this competition. And आपको भी बता दें यार कि देखो जिंदगी है जीत और हार तो होनी जरूरी है और उम्मीद यही करते हैं कि जितने बच्चों को फिलहाल हमने अभी हमारे बीच देखा है इनसे ज्यादा तादाद में अब हम फिलहाल यहाँ पर बाकी बच्चों को भी देखते जा रहे हैं। कहते हैं ना कि जीत के लिए सिर्फ जुनून चाहिए और जरूर अगर इस तरह इस स्टूडेंट्स के सवाल है तो हमें पता है कि हमारा देश सुरक्षित हाथों में है। With this, ladies and gentlemen, we move forward out here again. And let's have a moment for all these people to sit back on the dais. So we would really love to thank our honorable guest who's been such a beautiful part with us, and I would request, in fact, हमारे बीच में अतुल सर कि आप kindly हमारे बीच में present distinguished guest को हमारी तरफ से comment जरूर present करें। With the beautiful moment, now I will request this moment. In fact, my speech Prakash said NEERI. He would love to come and please guide us with what he has to say for the show for today.
Honorable dignitaries, our respected invitees, सभी मेरे साथी, students, teachers, मुझे क्या कहना है, मुझे कुछ नहीं कहना है। क्योंकि जिस उत्साह से इस कार्यक्रम की शुरुआत हुई और जितना हमने एक ऊर्जा अपने आप में थी सुबह तक, वो ऊर्जा एक झटके में पस्त हो गई जब पता चला कि हमारे जो माननीय हंसराज अय्यर जी जिनका कॉल आया कि वो पीएमओ आजकल पीएमओ तो पता है आपको पीएमओ का फोन आया कैंसिल लग रहा तो पीएमओ बोलते तो पहले तो समझ गया कि उनका दौरा कैंसिल हो गया तो एक झटका जरूर लगा लेकिन ऐसा है झटके से उबरना हमारा काम है और फिर से काम में लगना एक कहीं एक मन में कहीं एक अंत या फिर कहे कि उत्साह नहीं होता और फिर उत्साह हो भी जाता है तो उस चीज को हमने हमेशा इस कार्यक्रम के आयोजन में देखा है और बहुत सारे वर्षों से इस तरह के हम सदमे से गुजरे हैं और आपने भी देखा होगा कि एक सदमा ही होता है कि जब हम किसी को बुलाते हैं और जब आते नहीं तो किसी सदमे से कम नहीं है लेकिन अच्छा है कि हम आज आपके सामने खड़े हैं मतलब कुछ हुआ नहीं है आप हंस रहे हैं मुझे बहुत अच्छा लग रहा है क्योंकि जब आप लोग हंसते हैं तो हमारा हंस उत्साह काफी बढ़ जाता है और मुझे बहुत खुशी होती है सर तो अगर कोई नहीं भी आए तो कोई हमें रुकना नहीं है हमारा चलना काम है तो मुझे लगता है आज जो संदेश दिया है हमारे जो मुख्य अतिथि अपने आप देखिए जब कोई गेस्ट या फिर गेस्ट ऑफ ऑनर तो जब कोई नहीं आता है तो अपने आप अपग्रेड हो जाते हैं ये ऐसा हमें मतलब सिखाया गया है ये नहीं कहता कि मतलब ये प्रथा है, ये मुझे भी पता नहीं कि रजिस्टर में लिखा है, लेकिन सर आप मुख्य अतिथि हो गए हैं। अब ये हमारा सौभाग्य कहें या किसका पता नहीं, लेकिन हो गए आप तो फिर हंस पड़े आप। तो ये पता नहीं आप भी ढूंढिएगा कि ये ऐसा होता है क्या, क्योंकि मुझे कहीं प्रोसीजर तो मैंने देखी नहीं है इस तरह की, क्योंकि कुछ इवेंट मैनेजमेंट का जो मैंने जो शुरू से मेरा जो अनुभव रहा है तो उसमें, लेकिन मैं आज मैं कहने जा रहा हूँ क्योंकि मुझे अच्छा लग रहा है क्योंकि आप आज थोड़े अच्छे मिजाज में हैं। तो ये जो गेस्ट होते हैं जैसे डिस्टिंग्विश्ड गेस्ट है, चीफ गेस्ट है, गेस्ट ऑफ ऑनर है, स्पेशल गेस्ट है, बहुत सारे हमने संज्ञाएं दी है उसको। और अमूमन कहा जाता है कि जब कोई गेस्ट आते नहीं है तो हम उनको अपने आप जो है अपग्रेड करते जाते हैं। तो वो प्रथा चली आ रही है उसको, लेकिन इसका रीजन मुझे भी नहीं पता। तो आप मुझे पूछेंगे अगर कार्यक्रम के बाद कि ऐसा क्यों है, इसका कहीं ये लिटरेचर वगैरह सब तो ऐसा मेरे पास कुछ नहीं है। लेकिन सर हम बहुत खुशकिस्मत है कि आप आज आए यहाँ पर।
ऑटोमेटिक बिजनेस का सेपरेट नहीं
तो सर और आपका जो स्पीच भी था, जो आपका प्रेजेंटेशन था, वो रियल चीफ गेस्ट का ही था, क्योंकि जो हमें रिलेवेंस चाहिए था आज इसके दिन में, क्योंकि सीएसआर का जो फाउंडेशन है, फॉर्मेशन है, वो फॉर्मेशन ही इंडस्ट्री और जो दो वर्ड है इसमें, इंडस्ट्री और साइंटिफिक। तो साइंस तो हम करते ही हैं, लेकिन आपने जो इंडस्ट्री का पार्ट जो बताया वो बिल्कुल रिलेवेंट है, क्योंकि ग्रीन केमिस्ट्री और ग्रीन इंजीनियरिंग जो है ये जरूरत है। तो यहाँ पे जैसे हम एनवायरमेंटल असेसमेंट करते हैं तो वहां भी हमारा एक कोशिश होती है कि जो बेसलाइन हमारा जो स्टडी होता है या मैन्युफैक्चरिंग प्रोसेस हुए, तो उसमें आपने जो वैल्यूएशन किया कि जो आपने जो भी एस्पेक्ट्स बताए, मुझे लगता है हमारे जो साइंटिस्ट है और हमारे जो स्टाफ है और जो रिसर्च स्कॉलर्स है पर्टिकुलरली यंग उन्होंने नीरी को आगे बढ़ाना है, तो उनको मेरे ख्याल से काफी काम आया होगा, क्योंकि ये बहुत ग्रीन इंजीनियरिंग, ग्रीन केमिस्ट्री, किसी भी चीज को बिगिनिंग से ही उसको एक प्रोजेक्ट का एक इम्प्लीमेंट करना, उसको एक आकार देना उस तरह का, तो ये बहुत इंपॉर्टेंट है, क्योंकि इंडस्ट्री से ही जो है एमिशंस है, इक्विवेलेंट। तो आपने जो आज सीएसआईआर का जो आय है पर्टिकुलरली उसको आज आपने टारगेट किया अपने स्पीच में, और मुझे बहुत खुशी है। तो मुझे लगता है कि मैं फिर आ रहा हूँ, चीफ गेस्ट सही में चीफ गेस्ट थे और उनका जो रिलेवेंस था वो बिल्कुल इंडस्ट्रियल और इम्पैक्टफुल था, मतलब बहुत सारे आए थे उसमें। तो उसके लिए सर आपका बहुत बहुत थैंक्स। और मुझे लगता है कि मेरी आने वाले जो दिनों में अपने जो प्रोजेक्ट्स फॉर्मुलेट करेगा, तो शायद जो सर ने बताई जितनी भी चीजें ग्रीन इंजीनियरिंग, ग्रीन केमिस्ट्री की, उसमें हम सब प्रयास करेंगे। और दूसरा डायरेक्टर साहब ने जो कहा है परफॉर्मेंस इंडेक्स जो हमारा बताया कि पिछले 6 महीनों का, तो मुझे तो लगता है 6 महीने का तो इंडेक्स तो ठीक है, लेकिन हमारा पिछले 58 सालों का भी जो जितने भी 65-64 जितने भी साल है सर, उसका इंडेक्स भी मुझे लगता है कि हम पैरेलल ही चलेंगे, मतलब कोई ऐसा कहीं कम ज्यादा
वैसा चलेंगे।
वो तो जो इंडेक्स तो हम, जो हमारा जो ईसीएफ है, हमारा जो पब्लिकेशंस है, हमारा जो पेटेंट्स है, हम तीन ही पे क्यों ना हम मतलब इसको कुछ आगे बढ़ाए और कुछ इंडिकेटर्स इसमें जोड़े, मतलब और तो वो उस पे हमें ध्यान देने की जरूरत है आज के इसमें कि एक्चुअली मेरे को पूछेंगे आप ना, आज मैं आपको थोड़ा सा मैं खुल के बोलूंगा, आप मुझे यदि पूछेंगे कि मेरे लिए क्या इंडेक्स है तो मेरे लिए सोसाइटी, सही बताओ। सर का भी जो बताया, सर के स्पीच प्रेजेंटेशन में भी सोसाइटी अल्टीमेटली आया, वही के ट्रांसफॉर्मेशन जो है सोसाइटी के लिए चाहिए, तो मेरे लिए सोसाइटी है। और साइंस कोई कटिंग एज मेरे लिए नहीं है, साइंस साइंस है। कोई बोलता है कि मैंने ये साइंस यूज किया, वो साइंस यूज किया, लेकिन मेरे लिए अल्टीमेटली सोसाइटी, और सोसाइटी का मतलब मेरे लिए सबसे जो नीचे का तबका है, जो मतलब जो हम कहेंगे कि ग्राउंड लेवल पे जाने की, तो उस पे अगर हम कुछ डिलीवर कर सकते हैं, तो मेरा हमेशा प्रयास होता है। चापेकर सर बैठे यहाँ पे, बहुत सारे गणमान्य व्यक्ति है, और मेरी इच्छा है आप सबसे काम करने की, और मैं जुड़ूंगा आप लोगों के साथ। तो ये जो सोसाइटी के लिए जो करना है, इसके लिए किसी साइंस की जरूरत है, लेकिन इसके साथ बहुत सारी चीजें लगती है, और मेन है आपकी ऊर्जा, आपकी जो एनर्जी, आपका और इंटेंशन, आपका डिटर्मिनेशन, आपका पैशन, आपका कमिटमेंट, तो ये चीज सोसाइटी को, ऐसा नहीं है कि साइंस ही सब कुछ दे सकता है या मेरी, हमें सब मिलकर सोसाइटी की जो है नीति पे बहुत सारे काम करने हैं। तो मेरे लिए यदि कहेंगे तो सोसाइटी का, तो मैं इस पे ही अपना जो है इसी के साथ वोट ऑफ थैंक्स, तो पता नहीं मैंने थैंक्स तो एक भी बार नहीं किया है, लेकिन मैं भी कर देता हूँ मेरे स्पीच में कि सोसाइटी को लेकर ही मैं थैंक्स करता हूँ, क्योंकि जो आज के दिन सोसाइटी का ही थैंक्स, क्योंकि सोसाइटी का आप सभी पार्ट है, क्योंकि सोसाइटी के हर सेगमेंट का थैंक्स, जिन्होंने नेरी को लाइक किया, जिन्होंने नेरी को हमेशा सपोर्ट किया, जिन्होंने नेरी को हमेशा कोऑपरेट किया है, और नेरी सोसाइटी की बदौलत है, क्योंकि सोसाइटी रहेगी तो एनवायरमेंट रहेगा, एनवायरमेंट रहेगी तो इकोनॉमी रहेगा, इकोनॉमी रहेगी तो प्रॉस्पेरिटी, मतलब सारी चीजें इंटरलिंक है। तो नेरी हमारा जो है सोसाइटी से अभिन्न रूप से जुड़ा हुआ है। तो आप सभी का बहुत बहुत धन्यवाद, और यहाँ पे जितने और पर्टिकुलर स्टूडेंट्स टीचर्स आपका, और जो 25 इयर्स जिन्होंने कंप्लीट किया उनको बहुत फिर से बधाई, और जो रिटायर हो गए और जिन्होंने, और मुझे लगता है रिटायर होने का मतलब जैसे भारती साहब ने कहा था रिटायर करना रिटायर, तो मुझे लगता है कि जो सर्विसेज है कंटिन्यू रहेंगी आगे भी, क्योंकि नेरी ने बहुत कुछ हमें दिया है, अन्नदाता है, हमारी अन्नदाता है और रही है, और ऐसा नहीं कि रिटायर होने के बाद अन्नदाता नहीं है, पेंशन तभी हमें मिलती है। फिर हंसती आप, पेंशन नहीं मिलती क्या? मिलती तो है ना, तो मेरी से मिलती है, तो मेरे के प्रति तब भी रिटायर होने के बाद भी मेरी रिस्पॉन्सिबिलिटी है कि नहीं है? वही सर आप एग्री करते हैं? अच्छा, हो सकता है, लेकिन मोस्टली मैं सोचता हूँ कि मैं मानता हूँ कि एग्री करते होंगे। तो मेरी के जो हमारे रिटायर के बाद भी हमारा कुछ दायित्व बनता है और हम साथ में काम करें, ये मेरी इच्छा है और सबकी। तो इसी के साथ मैं आप सभी को, और निशा मैडम जो यहाँ पे कंपनी करने आई, उनका बहुत बहुत थैंक्स। एक्चुअली वो हमारी मित्र है, आकाशवाणी रेडियो का पूरा संचालन करती है, तो एक्चुअली मेरा एक फायदा है नेरी में रहने से कि जो मीडिया है, एटलीस्ट मीडिया के लोग, मीडिया को भी मैं थैंक्स देना चाहूंगा, प्रिंट और इलेक्ट्रॉनिक मीडिया, तो सारे प्रत्यक्ष या अप्रत्यक्ष रूप से जुड़े हुए हमारे साथ, नेरी के साथ, और पता है कि नेरी को लोगों तक ले जाने में मीडिया की बहुत अहम भूमिका रही है और आगे भी रहेगी। तो उनसे दोस्ती बनाने की हमारी भलाई है, लेकिन दुश्मनी, क्योंकि मीडिया से ना दोस्ती करो ना दुश्मनी उतना अच्छा है। दोस्ती भी करोगे तो भी वो आपको छोड़ेंगे नहीं अगर आपने गलत काम किया, और दुश्मनी की तो फिर छोड़ेंगे ही, दुश्मनी तो फिर तो अलग ही बात है। तो कुछ कैटेगरीज है सोसाइटी की जिससे हमें दूर रहना चाहिए। तो मेरे ख्याल से राजगढ़ साहब की, किरण राजगढ़ साहब तरुण भारत वाले उन मेरे से एग्री करेंगे, क्योंकि अगर हमारे के अगर गलत काम करते हैं तो वो आज मेरे फ्रेंड है, लेकिन वो मुझे छोड़ेंगे नहीं, तो साथ देंगे। लेकिन हम सर ऐसा काम नहीं करेंगे, हम अच्छा ही काम करेंगे, ये अच्छा काम करती है। तो इसी के साथ बहुत बहुत थैंक्स आप सभी का, और इसी के साथ मैं यहाँ पे अपने जो जितने डिविजन्स है, जितने सेक्शंस है, जितने एडमिनिस्ट्रेशन है, अकाउंट्स है, परचेज है, साइंटिफिक डिविजन है, सभी का बहुत बहुत थैंक्स कि आपका हमेशा कोऑपरेशन रहा है। और मैं यहाँ पे कार्यक्रम के समाप्ति की घोषणा करता हूँ, लेकिन एक अनाउंसमेंट है, डॉक्टर रितेश जी का जो नॉइस बैरियर है वो इनॉग्रेशन इसके बात करेंगे, क्योंकि कमिश्नर साहब ने कहा था कि मैं आऊंगा, वो कुछ मेट्रो की मीटिंग में है, लेकिन वो आए ही नहीं अभी तक, और ना तो मेरा फोन साइलेंट पे था, देख लेता हूँ यदि कॉल आई तो कुछ दिख नहीं रहा है। तो हम अभी इसके तुरंत बाद जो है इनॉग्रेशन करेंगे उसका, नॉइस का। और यहाँ पे अभी मैं आप सभी से विदा लेता हूँ, और आप सभी को अनुरोध करता हूँ कि राष्ट्रगान के लिए आप थोड़ा सा सम्मान के साथ